Mrs. Harbin, and we're doing video notes 2.1. I mean 2.2. Hey, you can see it right there. Alright, let's back it up. Just want you to know what you'll be learning. We're going to talk about the organization of the periodic table, periodic law, all the things on the periodic table, properties, chemical and physical properties, and different regions on the table. Okay? Alright, metals, nonmetals, metalloids. So we have a lot of things to look at. You already read some of this stuff, but I just want you to re-look at it in terms of what we're talking about now. And then these pages will be helpful too from chapter 11. Remember, there's going to be a slide at the end that's going to ask you some questions. So playing this song in honor of flame tests. Alright? You know it. So hey, guess what? It's 16th of the month. They're coming close. And so guess what's coming? My Oprah magazine. Yay. You might not get Oprah magazine. You might get Social Media Monthly or Orlando Arts. But what happens is that every time the 16th comes around, we're getting a periodical. These are called periodicals. So we get them periodically and it repeats. The pattern repeats. Oh, guess what? Time for my magazine because it's that time. It's the 16th of the month again. Woohoo. So periodic means repeating. There's something called the periodic law that helps us describe the beautiful organization of the periodic table. If you arrange atoms by atomic number, the trends will repeat. That's the periodic law. You might want to note that. Notice that we're saying atomic number. What do we mean by patterns or trends? Well, size of atoms is going to be a trend, and we'll talk about that. But there'll be a pattern going across, and guess what? We'll see the same pattern again, and the same pattern again. Charge is going to repeat. There's a pattern for charge going across, all right? And then you see the same pattern going across the next row on the periodic table. It's kind of like days of a week. So this was, say this was Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Guess what? The next row on your calendar would say Sunday, Monday, Tuesday, Wednesday. So anyway, a calendar is repeating. The periodic table has periodically repeating patterns, okay? So what are we going to call these different places on the periodic table? I put this on this way for sure, and for a reason. The columns on the periodic table are called families or groups. So this is a family. This is a column. This is a group. Family, column, group. Family, column, group. So up and down on the periodic table, the columns, like the Greek columns holding things up, those are the families. Okay? What do we call going across? Well, we call going across periods. Okay, so how many periods are on the periodic table? 1, 2, 3, 4, 5, 6, 7 periods on the periodic table. The periods are the rows. I like to say if you write a sentence, what do you put at the end? A period. Okay, so sentences go across, periods go across. All right, series. There are different series on the periodic table. Like this is a series, and this is a series. There are different series on the periodic table as well. What's a series? Well, it's a special show like The Simpsons. Woohoo! Okay, all right, Bart. Anyway, how does this periodic table get arranged the way it did? In about 1860-ish, Dmitri Mendeleev published a paper where he put the elements into patterns based on trends. What do we mean trends? He took atomic mass and put elements in order of increasing atomic mass, and when he did so and he made columns and rows, he saw certain patterns. All right. Now he used atomic mass, but the periodic law, I just said, uses atomic number. Why would Mendeleev use atomic mass? Because they didn't know about protons, neutrons, electrons yet. But he did see patterns in the behavior of elements and the properties of elements. And because of those patterns, he was able to predict that there were elements. So he only knew about 60 elements then. He predicted that other elements existed and where they would go on the periodic table. So things like germanium was predicted and then discovered. So Mendeleev's pattern arrangement of the periodic table was pretty sneaking nifty. And what he did was he used evidence and data to support his arrangement. Today we use atomic number because we know about protons, and that's what increases by 1. Who says science doesn't change? Thanks, Dimitri. So charge is periodic. So one of the things we talked about is that we could label the groups on the periodic table as 1 through 18 across. We could also label them A groups, 1A, 2A, skip a few, 3A, 4A, 5A, 6A, 7A, 8A. All right. Now, when we talk about charge being periodic, all these elements are neutral, but when these elements make a charged particle, they will make a +1 charged ion. These elements will make a +2 charged ion. Over here we have a +3, here we have a +4 or -4, and here we have a -3 ion, -2 ion, -1 ion, no ions at all whatsoever. So what does the plus mean? Those are losing electrons. What does the negative mean? Those are gaining electrons. Either way, this it's periodic. Lithium +1, beryllium +2, boron +3, carbon +or -4. Okay, nitrogen -3, oxygen -2, fluorine -1, neon 0. Repeat, +1, +2, yada, yada, yada. So it's a periodic pattern. Okay, regions of the periodic table. I'm going to draw a zigzag line in here. You'll see it often. Zigzag line, stair-step line is a separator. Separates what? Separates this side from this side. What are most elements? Most elements are metals. This is the metal side. Find something you know is a metal. Oh, look, silver's metal. Oh, look, iron's metal. Once you know it's a metal, then everything on the side it's on is a metal. Find something that's a nonmetal. Okay, oxygen's a nonmetal. It's not shiny. It's not malleable. So then this side of the stair-step are the nonmetals. What makes metals metals? Well, here are some properties. Luster or shininess. Metals are shiny. Metals conduct electricity. Metals are solid except for mercury. Metals are malleable. You can make things out of them, bend them into shapes. Most metals react with acid. Okay, so if those are all properties of metals and metals and nonmetals are opposite, guess what? Nonmetals are not those properties. Okay, so will a nonmetal be shiny? Probably not. Will a nonmetal conduct electricity? Probably not. Of course there's exceptions, but we're talking in general. Okay, what about those things along the line that kind of do both? For instance, silicon is actually shiny. What? Silicon conducts electricity. What? But it is not malleable. Huh? So semi-metals or metalloids have some of each property. Okay, kind of some metal properties, kind of some non-metal properties. All right, other regions of the periodic table. So down here you have what are called intertransition metals. Here you have transition metals, and you can tell by color. So transition metals, these are rare earth metals or intertransition metals. These are regions of the periodic table that are big sections. Okay, and then these are lanthanide series and actinide series. So there are different kinds of regions that we can label on the periodic table. Ohana means family. Hey, Lilo and Stitch. They say family means nobody is left behind or forgotten. When we're talking about families on a periodic table, remember up and down are families. Chemists say families are columns on the periodic table, and the elements in those columns have similar properties, kind of like a family. Okay, hydrogen's an orphan like Stitch, but he kind of gets adopted, right? So elements in the same family in the same column on the periodic table will have similar characteristics. Are they exactly the same? No. Think about your family. You are similar to your family, but not exactly the same. Okay. So let's learn the name of those special families. This group right here, group 1A, is called the alkali metals. Group 1A, group 1, or 1A, either way. 2A are the alkaline earth metals. So here are the 2A. And look, they're also coded here. Okay. There's the aluminum family, which is group 3A or just group 3. These are just group 1, 2 if you want. Group 3A or 3 is the aluminum family. Okay, 1. This is 2 or 2A. Okay, 3A. Okay, the carbon group, easy to find because it starts with carbon. It's group 4A or group 4. 4A or group 4. If you're counting all the way across, it's actually group 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. This is group 14 if you're counting across, but sometimes we call it group 4 of the tall groups. Okay, nitrogen is group 5A, oxygen is group 6A. You know what, I should probably have labeled these like this is 13, this is 14, this is 15, this is 16. The halogens, right? Fluorine, chlorine, bromine, iodine, astatine. They are all halogens, all right? And this is group 7A, or group 17. And then the noble gases, we talked about them a little already. They're group 8A, also known as group 18. They all have special names. So you have to know the special names of the families. Hardest ones are the ones that aren't called. So carbon family, easy. Nitrogen family, easy. Oxygen family, easy. But halogens, noble gases, alkali metals, alkaline earth metals. So you gotta get to know those. All right. So what does it mean to be in the same family on the periodic table? You're gonna have similar atomic sizes for your row. We'll talk about it in 2-3. Similar reactivity for your row. Okay. Identical charges for your row. You'll have the same ending electron configuration. Guess what? If you're in this row and you end in 2s2, then you will have different properties from that row and different properties from that row, but similar in the same row. Okay. All right. So are these traits periodic? Well, atomic mass. If you look at the pattern in atomic mass going across, it increases across that row. It increases again going that way, so it's periodic. Charge. +1, +2 going across this way. Guess what? The next row, same thing. So reactive, okay? These there'll be a pattern for these elements going across, and then you'll see the same pattern for those. All right. So periodicity is due to similar electron arrangements. Electron configurations are the same endings for in the same family. What does this mean? Let's check it out. Hey, we saw this before. Okay, so this is the alkali earth metal family. We got lithium, sodium, potassium, rubidium, cesium, francium. All right. So they all end in S1. This is 2s1. This is 3s1. This is 4s1. This is 5s1. So they all have the same ending electron configuration. What about next door? 2s2, 3s2. So they have beryllium, magnesium, calcium, all end in s2. So s1s, s2s. These are d1s, d2s. Here, except for helium, these are all going to be p6s. All right, so same ending configurations if you're a family. All right, to review, we'll light it up here. Families are groups, are columns, up and down. Periods go across. There's repeating traits. There's a pattern. Traits change but repeat. Yes, memorize the names of the groups. Periodic means repeating. Periodic means repeating. Periodic means repeating. All right. What is the periodic law? Go back and review that. And don't forget, right now we're using atomic number because we know about it. Mendeleev used atomic mass. All right, I told you about these sections. So these 4 questions, you should be able to answer them. Look at those pages, please. I know. One thing you'll notice is that once you open the book, you won't want to close it. So give yourself enough time. All right. I hope you guys have fun learning about the periodic table. Hopefully you learn these things. And I will see you soon. Peace out.